With section 7.4, we're going to start talking about vectors. And we have a very short homework to go over the questions here. The question says, use the parallelogram rule to find the magnitude of the resultant for the two forces shown in the figure. So one of the force is 7 pounds and the other force is 16 pounds. And the angle in between them is 60 degrees. So the parallelogram method, if we demonstrate what we have, the parallelogram method requires the forces to attach like this. And then when we connect them together to create a parallelogram, the resultant vector is going to end up right in the middle. This diagonal of the parallelogram will be the resultant vector. So if we draw what we have, this is the resultant vector that we have to find according to this question. And then one of the force is 7 pounds. And then the other side of triangle here, this side is always equal to the other side, which is 16. Now here, the difference is we have to focus this angle to apply the law of cosine here. In a parallelogram, these two angles will always add up to 180 degrees. If this is given as 60 degrees, the angle we're going to have to use for our law of cosine will be 120 degrees. Now we have everything for our resultant force, which is the sum of these two forces. So we're going to apply a law of cosine here, which will be r squared is equal to 7 squared plus 16 squared minus 2 times 7 times 16 times cosine of 120 degrees. Remember, cosine 120 is a negative number, which will just change this whole part a plus also. So when you ask to decimals and then enter this expression to decimals, 7 squared plus 16 squared minus 2 times 7 times 16 times cosine of 120 degrees, just make sure that your decimals is in degrees mode. The calculator will give you the answer as 20.4 for number 1 if you get the same numbers as me. For question 2, we have a very similar problem. We're going to still use the parallelogram rule, and we're going to find the magnitude of the resultant force. And then we have the two forces given and we have the angle given, and we're going to find the answer for the resultant force. Again, if we apply the parallelogram rule, let's just locate where is the resultant force is going to end up. Once we complete this to a parallelogram, this will be always the resultant force that we are looking for. So since I don't want to work on this complicated shape, I'm going to draw the triangle I need again. So this is what I want to solve for. This side is always equal to the opposite side, so it's 30. And this horizontal length is already given to us 29. So the only problem right now is this is the angle I need to find the resultant force. And then this angle will be found as 180 minus 116, which will be 64 degrees. Now for the resultant vector, the equation we have to set up on decimals will be 29 squared plus 30 squared minus 2 times 29 times 30 times cosine of 64. And we just have to make sure that the settings are in degrees so we can match this answer with these numbers given in this problem. The last question on the homework is, we have two forces act at a point in the plane. The angle between the two forces is given. So the shape is not given in this problem. So I'm going to draw my own shape. So I'm going to show that these are the two forces. We're going to find the resultant force. One of the force is 236 and the other force is 191 newtons. And their forming angle is 63 degrees. Just like the other problems, the resultant force, if we complete this to a parallelogram, according to the parallelogram method, the resultant force is going to start from here and it will end up here. So this diagonal of the parallelogram is what we need to solve for. So we're going to solve for this. And then this side of the triangle will always match with the given forces. One of the given forces, 191. And then this force is given as 236. The only difference is they gave us the angle between the two forces, but for the resultant force, we actually need to calculate this angle. But using the properties of parallelogram, these two angles will always add up to 180 degrees. So 180 minus 63 will be 117 degrees is what we need. Just like the other two problems, R is equal to, due to law of cosine, 236 squared plus 191 squared minus 2 times 236 times 191 times cosine of 117 degrees will give us the resultant vector.